Hello everyone, and we'll start in a few minutes. So today's, and everybody can hear me properly? Any echo or anything? Please feel free to say, otherwise the whole training will be struggling with the sound. Anybody who has joined first time Zoom, so you can use the audio to connect directly from the PC itself, or you can dial in. Of course, dialing in option is tedious. You can just click it and it works seamlessly across Mac, Windows, Linux platform, and even from mobile phone. And in this one, we will talk about like a journey to become a data engineer. And while doing so, we'll be demystifying some of the buzzwords around. And whenever anybody joins the data field, people are often confused between data engineer, data analytics, data scientist. Even for me, a couple of years back when I started, for me, it was like everything I thought is a data scientist. But over a period of time, I realized that there are a lot of difference. So we'll go through one by one. About questions and answers, so it's like a webinar style. So first, whatever presentation I have, I'll deliver. And then at the end of it, we will have a question. During the time, I will encourage you to go. If you have any question, just tweet it. The tweet is the only way I will be able to respond. I won't be able to respond on the chat. So and at the end of it, anybody has any question, it will be like an interactive session. You guys can raise your hand, Zoom, and unmute yourself, and we can start some discussion. So let's start. So data and AI landscape. So if I talk about right now about data and AI landscape, so we have pretty much across the industry, doesn't matter what is your business, right now everybody's talking about AI. And AI in terms, a lot of people are, when they say AI, it doesn't really mean that they are going to come up with the robots and to replace humanity and everything. In this AI context, what most enterprises are talking about, they want to use the data to advance their business. So data, again, when you're talking about AI in any term, it is artificial intelligence, of course, that's neural network base is there, which helps you to do completely simulation of human. That is completely different from what is mostly on the enterprise market I'm talking about. They're talking about using any kind of data, and they have the data from pretty much from 20 years. They have been collecting data. And the recent demand for data is only because of the way Facebook, Google, and all this Amazon, these giant Silicon Valley companies, they were able to leverage this data in order to advance their business disproportionately compared to any other industry. So what was the key benefit? Why they were able to so successful, and this legacy or traditional business model like banks, insurance companies, and how they missed out the whole data revolution. Like when Google, Facebook, and Amazon, they were heavily investing on their streamlining their data pipeline. And when they woke up, but they woke up pretty late because they woke up after they started reporting $1 trillion of market valuation. That changed the game, everything. Second thing was, so what was the real need from enterprise? So real need for enterprise was that when I say enterprise, I mean any company who is not a tech company. And they use technology to have their business. So Facebook, Amazon, Google, they are inherently tech company. But insurance company, manufacturer, bank, or any, if you go, you walk off your life, pretty much every company, they are non-tech company, but they are using technology to leverage their business problems. So same way, so they started investing heavily on the modernizing their data platform. When I say modernizing their data platform, mean they already had a very sophisticated data platform based on EDW, And now they want to modernize using open source technology. So it is a kind of a reinvention of the same thing. So having said that, because so much massive transformation is going on, there is, of course, a lot of demand for professionals who know or who can work with data. And when it comes to working with data, there are quite a few job roles out there, but often people try to paint everything as a data scientist, like everybody is data scientist, but which is not true. We'll see how it is different and how you'll see the data engineer is the key role. It is almost 80% of the work is done by data engineers or related roles, and only maybe 30 to 20% job is actually done by scientists and analytics work. But it doesn't mean any work is easy. It's just I'm talking about scope of their job during the course of data pipeline. So before I go into that, so this is the last thing, that so many, the requirement for these data professionals has skyrocketed. Doesn't matter which part of the world you are, there is a high demand for data professional and data application. So before I talk about what is data jobs, first I want to highlight about the basic data pipeline in anywhere in the world, anywhere. Whenever you're talking about data pipeline, usually in nutshell, they have few steps. So I call them the 3 steps. One is what? You have data acquiring, which could mean data gathering. Because if you do not have data, there is no data science or data engineering, anything. So data gathering could be any kind of operation. Simple example is sampling. Or maybe you go to a say Walmart, they give you a loyalty card. In that loyalty card, that is also a data gathering. Because using that loyalty card, they are able to see your shopping behavior, and based on that, they may send you some flyers or something. That is a legacy style of data aggregation. Another data gathering is when you go to LinkedIn or Facebook, you give all your personal information out there. That is another data gathering, because those companies are able to, they know more about you than you know about yourself, because now they know the personal information and plus they know the behavior data. So there are many ways you can actually get the data. So when you get the data, and second step is actually data ingestion. So there is data sampling, and once the data has been acquired, that particular data has to be put in a very neat and clean fashion so that anything could be done. So once you've got the data, second step is usually put the data into your system, probably in your database. Like if you enter a Facebook profile, Facebook saves your data in a backend. Before they used to use MySQL, now they use Cassandra, and pretty much in million other types of software they use to save the data. So in a nutshell, if you're going to any basic simple, you put your data, the data is stored. So you can say it's a kind of a data aggregation, acquiring, or you can say data ingestion in a real technical word. Second is your data preparation. Data preparation could be known as a data wrangling, data cleaning, or transformation. So data preparation is a really big task. How it is? Because usually when your data is there, but often the case what happens is data is really bad. So simple example, if some company or some organization wants to aggregate your data, say social media data, say they want to see what you're doing in your Twitter, Facebook, and Amazon and your bank account, something like that. So if you see, there are 4 sources I just talked about, and each of these sources have a different data format. So in Twitter, your data will be, when you extract, it will be in a JSON format. If I extract your credit card information, it will be in a CSV format. And again, I go to Facebook, it will be completely different format. And if someone is doing some kind of a web scraping on your job site or Indeed or somewhere, data is different format. And now every data is a different format, and now you need to unify the data in such a way that, assume I'm talking about say Stephanie, someone. If I want to see her data across different platforms, so how will I do that? I have to find a unique identification, which could be me, or could be phone number, or could be anything like that. Say Mike is a keyword of the user Mike. I put that name, and now I need to find their all data, like their Facebook data, and I have to put in a very clean way so that now I can see the data and do some other work. A simple day-to-day example, I will say, if someone is a tester or a BA or anything, what they do basically. Once someone gives you data in a CSV, what you do some kind of filtering. Basic filtering, you remove any null character, you remove any garbage character, something like that. So whatever you're doing right now, you are actually doing very basic form of data cleaning or data wrangling. Another common data wrangling is unifying your date for time format. If you've traveled in different countries, pretty much every country has their own style of presenting the date, and that is a big pain. So even formatting the date into a unique format could be a challenging task. So these all tasks, these are a very simple example I gave, but these small tasks are example of data preparation. And the last, once the data is prepared and everything, now the task comes for data scientists. Data scientists, what they will do, they will see the data. And now the real work start of a data scientist, which is you're doing feature engineering, seeing distribution of the data. Okay, if my data is normally distributed or not. And because most of the data science algorithms are designed assuming that data is normally distributed, usually as a data scientist, what you do, you tweak the data a little bit. You take a log of data. You do a lot of things to make the data as close as possible to normally distributed, or maybe you take the sample of the data which is normally distributed, then you can run some models, do some testing, and then you basically come up with some kind of target variable, input variable, so on and so forth. And once you have done all these things, output is usually used by analytics people and everything. So this is a quick example I give you. This is what any data pipeline looks like. So now let's go back to, I will take one by one job, like a job, and I'll see some jobs in Indeed and see how it looks like. And then we'll come back at the end and see what skills are needed. And then you can choose that which job role or which field is closer to where you are. So then it will help you to make better judgment. Confusion of roles. As usual, data analytics, data engineer, data scientist, what they are, what is the difference between these people, and how they do. And for me, they are like each job is a very, very different job in its own way. And pretty much you need completely different bachelor degree for each and every job. So we'll dig upon it. First, we'll start with data analytics. So most people confuse it with data scientists, but they are not data scientists. Data analytics, they usually do on the cleaned data. So in these, they do not do any kind of prediction, not necessarily prediction. Most work is they do on data visualization. There is no machine learning at all. So data analytics, if you see what you are thinking, it is completely different from what you think as a data scientist. So data analytics is usually you are seeing the data, exploring the data, and doing some analysis. So skill set I'm talking about, data analytics skill, it's mostly non-technical people, like it could be anybody, it could be your like sales representative, or it could be business analyst, or these kind of roles, even a test automation, anybody could be data analyst. Most of the popular tool that you use is a Microsoft Excel. If you're a little bit advanced, probably you'll be using Python, because nowadays I did one more webinar last week. We talked about business analysts using Python. In that, we highlighted that how even the business analyst job is becoming more and more technical, and people are demanding them to learn how to code. So that was I will send you a link about that. You can take a look. So Python, good to have skill. Power BI is another visualization tool. Or Tableau is very popular. When it comes to qualification, we are looking for any high school diploma, any bachelor degree, doesn't matter, and basic stats knowledge. Like it's good to have stat knowledge, like mean, mode, median, what is it, if someone is talking about 2 standard deviation away, 3 standard deviation away, what is normally distributed data? These kind of basic concept helps you in a long way. So these are the skills I'm talking about in data analytics. So data analytics job titles could be business analyst, data analyst, system analyst, sales analyst. So these kind of profiles that you can do, and there are various kind of roles are available. And this is the most widespread role for anybody who is non-technical background. I mean, who hasn't done a master's in econometrics or master's in statistics or you just have done some bachelor's, maybe in commerce, science, biology, anything, and you can get on with it pretty short period of time. And this is a very rewarding career as well, because now with the cloud-based tools, doing data analytics has become a piece of cake. One of the webinar we did, we showed how you can do quickly sentiment analysis and industry grade using AWS APIs. And it's just mind-boggling how quickly you can do that. So you can take a look on that also. And so these are some of the data analytics job roles. Next is now data scientists. So now see data scientists what they do. They do data wrangling, yes. They do feature engineering, yes. This is the main bread and butter, feature engineering. They build models on the data. They predict the outcome. Machine learning is involved. They should be aware of most of the algos and must know few algorithms very well. Nobody can know everything. Again, whenever you're looking for something, don't expect everybody's Elon Musk. Okay, you know one or two algorithms very well and aware about other. As a programming skill set, I'm talking about Python, Spark, R is a good to have, and nowadays Python has become more or less must. If you're coming from traditional background, you have a SAS. So data scientist skill sets, aware of most algorithms but knows few algorithms very well. Experience in math and stats. That is the most important thing I want to highlight. You should have very good understanding of math and statistical background, otherwise it becomes challenging. It's not like you cannot do it. Of course, everybody can do everything, just a little bit more effort. Ability to learn new algos quickly. This is another key factor. Every day, pretty much new open source algorithms are coming out, and you should be able to pick them up pretty quickly. Qualification. So as I said, most algos, experience in math, ability to learn, these are the key skills. And now let's talk about data engineer. So data engineer, essentially a software developer. A data engineer, you cannot say if you're not a developer, it's very hard to sell as a data engineer. We'll see in more detail. So what they do, they help prepare the data for data analytics and data engineer. So before even a data scientist or data analyst start their work, they need an army of data engineers to build the platform, to have the data pipeline ready and everything clean and ready. It is like, chef. So assume if a data analyst or data scientist is a chef, so whoever is helping to get the chef its minimum ingredients, those jobs are done by data engineers. And that is one of the most heavy lifting job. 80% of the job involves that. So they work in data pipeline, data lake, or data warehouse, depending on which time you're talking about. These are different paradigms, and we'll touch base on a little bit on a while. So data engineer skill set, experience working with various databases, that is the key. You should have understanding of working with different databases, MySQL, Oracle, Elasticsearch, and when I say databases, I mean data. I will say like data sources as well. Apache Kafka, able to web scraping. So you should be a handy software developer to begin with. Big data experience is nowadays is must, because most of the organization, they are moving from their legacy EDW based data warehouse to a data lake paradigm. So this is one of the key skills that as a data engineer should understand. What is data lake, what is the EDW, and what is different between a streaming and a batch, something like that. These concepts you should understand. So these are the key skills I'm talking about. So traditional data engineer job, it used to be always like ETL developer, DBA, data warehouse professional. These are the legacy job I'm talking about. This has been there. So if I see any of the recent jobs in Toronto right now, if I look for data engineer in LinkedIn or in Indeed, I see they're looking for mostly for someone with, most of it, they know SQL, MySQL, and these kind of more of a technical job. Another data engineer popular job, if you see all the time in LinkedIn, these type of, pretty much if you see implementation of warehouse using Amazon Redshift. No Spark, Scala, Python, AWS, EMR, only EMR and EC2, S3. So these are a lot of technologies are there. But again, if you now start to pick and choose one technology, start learning, it will be years before you go somewhere. But the key is that you have to understand the concept behind it, because pretty much everything is same. Even if you take an example, AWS DynamoDB. What is DynamoDB? If someone asks, if I don't know, but if I know DynamoDB is a kind of a NoSQL database, and I have worked in one of the NoSQL databases, Elasticsearch, Cassandra, or anything, I'm good to go with any time. It's just a matter of APIs, and I should be good to go in few weeks. So the key should focus should be learning the basic fundamentals rather than chasing behind the buzzword. So of course, salary ranges are good in these cases. So data engineer, before you get into data engineering, you should have some data engineering concepts like what is hot path, cold path about data, various data paths, hot path, cold path, which is right now on-demand data, legacy data. No SQL, this is like a holy grail of anything. Okay, what kind of database you should choose when you're designing your data platform? No SQL or SQL. It's a big debate there is on which is good, which is bad. Every system has its own pros and cons, so you have to be able to judge about it. Distributed computing system and data platform. So you should understand what are the various distributed computing system out there and how it is better or worse than centralized computing system. Understanding EDW, your enterprise data warehousing versus data lake paradigm, the difference between these two. So these are basic concepts to begin with. And then you have data engineering skills. So skill, when I'm talking about, Java is always a rock star language. It is always good to have because it makes you very versatile to work anywhere. If you are not coming from a software developer background, getting Java will be really hard. So I would say choose Python because Python is designed and mostly towards non-programmer people so that they can get on board into it. So Python could be a very good starting point for someone with no software development background. Scala is again, once you have graduated from Java, then you go to Scala. Scala is a little bit even harder learning curve. But again, the more harder the language is, it is more powerful. Always remember, what comes for cheap is not good. What is good isn't cheap. It's just old school, right? Say you buy a car, Porsche, and you buy a, say, Toyota. See, you can say, yeah, I can drive both car in both ways, but of course, Porsche is Porsche and Toyota is Toyota. So you cannot compare. So again, Java is a very hard to learn language, but again, capabilities are also very, very flexible, very powerful. Python is very easy to learn. Of course, when it goes beyond certain complexity, usually people rewrite the stuff in Java. But again, most cases, 90% of the use cases here, Python can do pretty well. Platforms, understanding of Hadoop. Hadoop is an open source platform. What is going on nowadays is a new kid in the town, Snowflake. Everybody's talking about Snowflake platform. They're able to handle any kind of data amount, hot and cold path. On cloud, I will say if you're on beginning on the cloud, start with AWS because this is kind of a gold standard. So beginning with few of the AWS key products, S3, EMR, RDS, Kinesis, DynamoDB. Don't start doing everything on AWS because AWS is ocean. Every day they are launching hundreds of products and it is humanly impossible for anybody to know all of these. So again, just start with it. Again, some people talk about should I take certification. Again, if you have no or zero experience, certification may help you to validate your knowledge. But again, if I'm interviewing someone, I don't care about certification because they're just objective type questions. So it's again, it definitely adds a value into your resume if you're looking to get into the market. Data engineer tools, all buzzword. If you must have heard Apache Hadoop, Apache Kafka, Apache NiFi, Airflow, Elasticsearch like NoSQL database, MongoDB. Of course, our old friends Oracle, MySQL, PGSQL, Teradata, AWS RDS. RDS is their relational cloud database. So basically, if you want to use a MySQL or in Amazon, you can go to RDS and it's ready to use kind of thing. BigQuery is Google's SQL, big SQL. Google's query. Cosmos DB is their Amazon's NoSQL database. So these are some of the tools. So let's come back to again our favorite data pipeline. Just to showcase, we talked about at the beginning, right? How the data pipeline acquiring, data preparation, and data analysis. So now if I check back my thing, what I see, data acquiring, whom we need? Data engineer, because they are the software developer. They will be able to scrape the data, quickly write a code, ingest, troubleshoot. If your data need into the cloud, they can get into the cloud. Getting data from cloud, that you need a developer. Data engineer is right there. Data prep, a lot of data prep involves moving data around here, there, aggregating. So again, you need a data engineer. And here, data scientist also chips in because you may have to needs certain input from data scientists. Okay, which fields, like take an example, hey, I'm pulling the whole table. Which fields do you need most for your model? You say, okay, I only need the name, salary, and the age from this guy. I don't need anything else. Because for my model, everything else like is maybe a zip code is not important. Assume some kind of algorithm you're running model where zip code is not necessary. Then data engineer will prepare a query, SQL query, will fire it or something like that, and will give the data to that data engineer. So it's always back and forth between data scientist and data engineer. So again, they chip in. And when it comes to data analysis, data scientists and data analytics. So basically, data scientists build the model, did the feature engineering, predictive model. He says, okay, this is a prediction. And based on that, some analysis a data analytic can do after everything has been done. So these are the data pipelines. So some of the skill set I'm talking about. So we have like this is so becoming a data engineer. So this involves a lot of things and a lot of technologies to learn. So this was the presentation from my side. If you guys have any question, please feel free to unmute yourself and ask the question, and I'll be happy to answer. Okay, no questions, fine. So it's all about this. So just want to introduce that. Okay, these are the data engineer. If you are looking for any career or anything, first you have to choose which area you want to go. You want to be a data engineer or data analytics or data scientist or something like that. I mean, don't go like again. If you do not have any software development background or you do not want to become a software developer, then do not choose this path for data engineer. This is the period. So again, data engineer could be very good for someone who has background in QA, automation testing, has done other kind of software development, and even DBAs, database administrators. So these are the target people who can actually upgrade themselves, or even the legacy ETL developers, they can upgrade to data engineer work with some of the skill upgrade and get into a better situation. If you have completely non-technical background, then I will say just pick the data analytics part. That is a very good hot situation. You may be using Excel sheet already, and you just need to learn a little bit Python to do better in your job. And if you're looking for a really hardcore data scientist, and then it is good to have math skills. Again, if you do not have, assume you have no math degree. So assume just add maybe 2-3 years it will take you to become a decent data scientist to understand what is going on. So this is the background about what is. So coming back to my slide. So we are current next month we are launching a AWS data engineer training program. In that we will cover these of the topics: AWS data stack. So we'll cover EC2, S3, RDS, and EMR. How to get your data. Yes. Answering to Venkatesh. Yes, for an ETL developer without Java experience, yes, you can. Data engineer is the right path. Yes. Anybody else? Question? So you feel free to post the question here. So the next training that we are planning next month, it is AWS data engineer, because pretty much everybody is talking about AWS and you have to have this basic skill. So in that training, we'll be covering this AWS data stack, EC2, S3, RDS, and EMR. EMR is actually Amazon's Hadoop kind of. You can say it's called Elastic MapReduce, and Hadoop came from MapReduce paradigm of programming. So it's called, their marketing name is called EMR. And we'll be also training on Elasticsearch. Elasticsearch is an open source NoSQL database. So we'll be using these kind of things, like either, again, the course will be a little bit tailored towards, if someone is coming from a software developer background, then the whole material will be taught in Java. Or anybody who is not coming from hardcore software development background, the whole material will be taught in Python. It is as simple as that, just to make the life easy. Apache Kafka, We'll see how we can stream. Again, nowadays, if you see a lot of streaming data going on, you must have heard batch data, stream data. So anytime you're looking for a stream analytics or stream work, it is also Apache Kafka is the hottest tool. It was invented by LinkedIn and being open source, and it is used by Uber. Pretty much every big streaming company, they're using Apache Kafka nowadays. Apache Hadoop, yes, although a lot of people will talk about is legacy, but Hadoop is still out there, and it is very essential that you know Hadoop. And Apache Spark on PySpark will teach on. And again, if some of you are a Java person, you have software development, it will be taught in Java or Scala. What software skills are necessary for AWS data engineer? Software skills, I'm not sure if you heard. So software skills for AWS, basic understanding of software, I will talk about this. So if you're talking about AWS data engineer, so basically understand these AWS products, like what is EC2, what is S3, these things. And during our training, we'll teach Python as well, because basic Python you need. So that how you can basically, say assume I'm a data engineer and I want to create a data pipeline, say scraping tweet, just basic example, scraping tweet and scraping a CSV file from somewhere and just aggregating the data and bringing the data into, say, Amazon S3. And once the data is on S3, I can use some kind of maybe Amazon Lambda to trigger certain events, or maybe an EMR job to trigger it, and then basically output could be put in again back to S3. So this thing you may not need even a Java any programming. You can do on a web GUI also. But the key is that the person who is doing a web GUI, nobody wants to hire him or her, because see, the moment you start using click, 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 it means you are no longer a software developer. You become an operation person. So again, operation person, the moment anything goes, so it's a different kind of role I'm talking about. But if a software developer approach, what to do, they will use, say, Amazon APIs, REST APIs, or Bodo libraries to actually automatically do the whole thing. So basically use a Python to scrape through the Twitter, get the data, and put into S3, and everything programmatically. So when I'm talking about data engineer, I'm talking about everything doing programmatically. And if you do not have software background, it will be completely on Python. So in Python, we say, okay, how to get the data from, say, somewhere and put in Elasticsearch. Or maybe how to get the data somewhere and put in a Kafka, and how you can use KSQL. And usually data pipeline nowadays looks like people get the data from somewhere, say online, and then they put in their own data platform, could be on Apache Kafka. And after the data is there, then maybe you want to do some kind of data aggregation. You take bunch of topics, put in somewhere, do some kind of basic data parsing or data cleaning, wrangling, and put the data into Elasticsearch. This is one option. Again, hot data, cold data. If you really want the data immediate access, you put on Elasticsearch for a fast access. For a slow query access, you can of course put in a Hadoop or a Hive, so that then legacy data can be done by some other kind of person. Again, Apache Spark is a very specific use case. Spark is a really huge platform. So probably it will take, so in this case, we'll use any of the cloud Spark provider to basically do something, how you can use something in the cloud. So basically getting the data from maybe internet or somewhere. And we'll, in the all example, we'll try to use as close as possible use case where you get the data, and the end, the data should be ready to build a model. That is the goal. See, the whole, again, the data engineer, this one, it is not just to write some code. It also focus on, once you spit out the data from any data pipeline, that data should be able to go into a model. It means data must be clean. Even if you're doing a JSON parsing, simple JSON, make sure you filter. One of the webinar we did about doing some sentiment analysis. So in sentiment analysis, most of the algorithm, they are written for certain language. So assume my sentiment analysis algorithm only works for English. So if I'm scraping tweet for 1 hour, does it make any sense to have a Spanish or maybe other Hindi or any other kind of language? No, it doesn't make sense. So what you have to do, you have to filter out the data. This is a very basic way of cleaning the data. So you remove anything which is not English, just bring the data. Again, if your algorithm is not capable of handling emojis, a lot of emojis are in tweets, so you have to, again, throw out all the data, because those data which cannot be fed into a model is garbage. and you do not want garbage in your model, because always said in AI world that garbage in, garbage out. If the data is coming as garbage, your model is as bad as the data. So, and this is the one of the reason that why so many enterprise trying to get to AI ready or whatever, because their data is not ready. Their data is not good enough to run any model. And that is where the Silicon Valley companies champ, because they know the data and they handle the data pipeline extremely well. So this is this is why it puts a tremendous opportunity as a data engineer. Again, it may be on some of the ETL developers may find they're out of the place as things are moving towards data engineer. But again, on one side, okay, you may be out of the place, but on the other side, you see there's a tremendous opportunity to be a data engineer and just get paid double the amount of ETL. So these are the few things. So this is for the data engineer. Again, if you think you're not ready for data engineer or something like that, so then you choose for a analytics. So Python for analytics. So this is mostly designed for non-technical person who wants to just improve their productivity in their existing job. If you're doing anything using Excel or anything, this is the right tool for you. You do some kind of, a little bit of DBA or something, you do these kind of course and you get into understanding of it, data analytics. And if you really want to get into and you have some background, and this is pretty obviously for advanced user, for advanced data science and machine learning. So in that one, you will be talking about regression, how to do different kind of random forest, artificial neural networks, gradient boosting. So we'll be focusing on that. Again, in this one, assumption is that you already know and understand Python. You have basic understanding of statistics and the data, and then you can talk about what is linear regression and logistic regression. Again, if you come, hey, I don't know what is normally distributed data, then this is not the right course for you. Probably you should do something else. Maybe go back to the Python for analytics. So these are the courses that we offer. And that's for me. Any more question you guys have? We have few minutes. We have 4 more minutes. We can anybody can unmute yourself and ask if you want anything. What are the top again, there is not exactly a, see, again, nobody can certify you as a developer, right? So again, if you're looking for a specific certification, you may be able to do, if you are really looking for cloud, maybe Amazon certification may be good to get into. Probably they are selling, because it's a huge market certification Amazon is doing, so pretty much they are selling certification for everything. So I'm not sure if they have a data engineer certificate, because usually they have certificate for, say, DevOps or solution architect. So I will say, again, if you just want to get a certificate, I mean, you can Google it, pretty much any certification. But if you really want to learn and something, then you have to be ready to invest some time and effort. And certification, I will say, I mean, personally, I'm not a big fan of certification. And I have trained a lot of people who are Amazon certified solution architect, and they just can't write 2 pieces of code. So again, certification has its values, especially if you just want to enter. Definitely helps. But again, certification by itself will not give you any knowledge. It will validate your, even Amazon says, validate your skills, validate your knowledge. It doesn't mean that you become like a pro or something. So there's a difference between certification and a degree. So you go for engineering college, you study 4 years of computer science. And someone thinks that, okay, so someone studied 4 years only programming language, only computer science. And you do a certificate for 1 month and you will surpass all the work. No, it doesn't work like that. Certification may get into the starting point, then you have to build on. Again, every training what that we provide, we always ask people, they give assignment and we follow up and everything, that we will do our due diligence, but you have to try on your side as well. And as a matter of fact, we do provide completion certificate, as a matter of fact, completion certificate, so that if someone is looking for a reference call, we are always there for that. Any more question? I think we are about to end, only 1 more minute. How does data engineer as a career path? Do you recommend getting more familiar with Python, Hadoop? Kindly include me. Okay, sure. Yeah, I mean, data engineering career, as I said, basic software development cycle is there. And don't go completely crazy with, you don't have to do AWS, GCP, and there is every new day there will be cloud. Tomorrow there will be Apple Cloud. So what, will you learn if everything new again? Because these guys will keep creating cloud. There is no end of learning. So focus on the learning the fundamentals. So take an example. If I know how the NoSQL database works, Elasticsearch, now it really doesn't matter if it is Amazon's Elasticsearch or Google's Elasticsearch or Azure's Elasticsearch or DynamoDB, whatever, the concept remains the same. Same way, when you learn how to drive a car, you don't learn how to drive a Toyota, how to drive a Porsche. You drive the same way. But if you just focus on, okay, I need to get Porsche, then I can only drive. Otherwise, I cannot drive. So you have to get away from that mindset. You don't need Porsche in order to learn driving. You can start with Toyota. Once you learn driving, you can drive pretty much anything, because every day new car is coming and you cannot say, okay, I need to learn every car set. So same philosophy applies. So data engineer is a general framework. You learn basic building blocks that I mentioned in the training also. That building block will give you a launch pad. From that, tomorrow Amazon comes, Google comes, whoever, whatever, it doesn't matter. These are all using the same fundamental principle, same laws of computer science and physics and data. It's not coming from the sky. So you should be able to apply and able to quickly translate your skill from one to another. Okay, thanks. Okay, thank you everybody for joining the webinar, and hope to see you on the next one. And I will be emailing, you will get an email automatically for the recording of the session, and have a great evening. Okay, bye.